Hello class, this is Ms. Choi. Hopefully you were able to get the email or the reminder. Alright, remember, let me know if that is not working for you. So we are working more on position time graphs today. So first of all, you should be able to decide from today's video whether or not a graph is going forwards. Remember, we call this the positive direction, or backwards, which would be the negative direction. You also should be able to know if it has constant speed or velocity, or is there acceleration. Also, is it going towards or away from the origin? The origin is essentially what we call where we decide to put 0. It's essentially arbitrary, we get to decide, but that's where the 0 goes. You also will need to be able to find position. That's going to essentially be, looking at your graph, finding a point on your graph, but also velocity. Remember, we talked about slope, and we need to be able to figure out what is the velocity from the slope of your position graph. Alright, so we're going to first work on what constant velocity looks like. We did work up this in class when you guys were walking the line, but let's start with, let's say we have a car that's here. This is where it's starting, so this is at our 0-second mark. I'm going to change the colors just so it's easier for you to see the difference. Let's say it goes to the left, and at 1 second it's at the 1 meter mark. Then in one more second, 2 seconds later, it's going to be at the -1 mark, and 3 seconds later, it's going to be here at the -3 mark. So right now, I want you to pause and try to graph this on your graph that you have and figure out how does this graph look. Alright, so I've added notches on my graph. They go up by 1. I'm not going to write it because I cannot write that tiny with a stylus. So at 0 seconds, we were at time equals 0, and we went up 3 meters. Right? We're doing things mostly in meters. Then as time went on, 1 second later, it was at the 1 meter mark. 2 seconds later, it was at the -1 meter mark. And 3 seconds later, it was at the -3 meter marks. So if I can draw a straight line here, mostly just a little above, imagine that was slightly lower, we have a straight line which shows us there is indeed a constant velocity. Alright, and then notice that the slope of our line, remember we're going downhill, that means we have a negative slope. And it's negative because we started on the positive side and then went towards the negative side. So in summary, constant velocity means that you have a straight line on your position versus time graph. And secondly, remember, if we have a positive slope, that means we're moving forward, but in this graph we're moving backwards, so we have a negative slope. Alright, so we worked on this a bit again today, talking about acceleration with position graphs. So again, say I got a little car, and it's kind of going slow here, kind of going slow, and it starts to speed up and go really, really fast here towards the end, signified by the huge arrows. So what does that look like if we were to graph it? So I'm not going to expect exact numbers when we're talking about this. I just want to see a general what's going to happen. So we start off going pretty slow, we're not going very far, and then we start going very far very quickly. So here, this is with a constant acceleration. A bit off the way here. So this is going to be constant acceleration. I will just say A. So a way to tell if your acceleration is either positive or negative really quickly is you kind of can just look at your graph. And the easy way is if it kind of looks like a happy face, you got positive acceleration, right? We're increasing. Or if it looks like a frowny face, you have negative acceleration. Alright, so now we have a graph and I labeled it for you with Roman numerals for each section. So what I want you to do is pause it and look at each section and figure out what is happening. So kind of like what we did today in class with the walking. What's happening, but just in each tiny section. Alright, so now that you've written down what you think, I want to go over it. So at Roman numeral 1, what's happening is, right, we start at 4. That's where we started. And then we are walking away, or walking forward. Alright, then at 2, right, we were just at 5 for that whole time, so you were just standing. No movement there. And then looking at 3, you're actually going towards the origin, or towards 0. So this would be, we're walking now to the left, or backwards. But, so we're walking towards the origin, aka 0. At 4, again, we've stopped walking towards origin, and we are again just standing, not going anywhere. And then 5, we are walking away from the origin. We're walking essentially through the origin. So we were in the positive area, and we are transitioning into the negative. So we're walking through the origin, or through 0 on our line in the classroom. So here we've ended negative, but we started at positive 2. So in this 1 second, we've gone 4 meters backward. Alright, so that's something, keep in mind. We are technically going from positive to negative, so we are going backwards. Alright, next we want to find the velocity. So remember, velocity is the speed, so it's essentially the change in position over time. Remember we talked about what delta means. So that'd be delta x position over delta t. From here, it's essentially, right, your x in this one is going to be your rise. And then your t is going to be your run. So just like in math, just when we're finding the slope, it's still what you're doing. So essentially here we can say that our velocity is equal to the slope at whatever point we're talking about. So I would like to practice this. So I'm going to pick some points along this graph, and I want you to tell me what's happening to the slope at that point. Alright, so what is the slope at this point? Let's call that A. What's the slope at this point? Let's call that B. What is the slope at this point? Oops, let me draw that down here. At this point, we'll call it C. And then, what is the point, or what is the slope at this point? We shall call that D. So go ahead, pause, figure out what the slopes are at each of those points. Alright, so looking at the first one, you can kind of see that it went over 1 and went up 1. I am going to do the math for that, however. So our change in our rise would be our final was 5, our initial was 4, and then for our time, right, our final was 1 and our initial was 0. So that's going to give us 1 over 1, which is still 1, and this is going to be, remember, in meters per second, because our units for our position are in meters, our units for our time is in seconds. Moving on to B. Well, let's look. Does it have a rise? Well, it's flat, so no, it doesn't. your rise is 0. 0 over any number, in this case 1, is going to be 0 meters per second. Moving on to C. So C, our initial point here, and our final point here. So our final, remember it's rise over run, so our final rise is at 2. Subtract your initial rise, which was 5. This is over your run, which our final run was at 3, our initial run was at 2. So 2 minus 5, so remember, that's going to be negative, so it's negative 3 over a 1, which is going to give you negative 3 meters per second. And then we can look at D. Now, D is a pretty long line. You can pick any 2 points on you want because it is a straight line. I'm going to pick this point here on the origin and this point here at 9 seconds. So I'm just going to go 1 second away to make it easy to solve. So rise over run, you can see we've risen 1 again. But if you're not sure, our rise was at 1, our initial rise was 0, and our final seconds was 9, our initial seconds was 8. This is also going to give us 1 over 1, which gives us 1 meter per second. And hopefully you can kind of see that the slope here in A, it looks like the same slope here at D. They're parallel, so it makes sense that you were going the same speed at those times. Alright, so remember, these are all just your velocities. Finding the slope gives you the velocity from a position time graph. Alright, we'll go for more practice. Alright, so I have another graph for you to practice. So I want you to find the velocity at 1 second, 6 seconds, and 16 seconds. Try it on your own. Alright, so remember, we're finding the velocity at each one of these times. We just need to find 2 points. This, to me, you can pick any 2 points as long as they're still on that line. I just picked those. So we can see it rose from 6, or negative 6 to 6. So that's a very large rise. That's a rise of 12. If you would like to do the math, feel free. It's a rise of 12 meters. And then we can see we've gone over in that time 4 seconds. So our run is a change in 4 seconds. So 12 divided by 4 gives us 3 meters per second. So we're going pretty fast there. You can go ahead and look at 6 seconds. So we have 0 rise here. There's no rising going on. So we could divide it by however much we want, but it's still going to be 0. So your velocity is 0 meters per second at 6 seconds. Then at 16, remember, any 2 points on this line will do. I picked these 2 points. So we can easily see that the rise went from negative 2 to 2. That gives us 4. If it makes it easier for you to see, you can see that we went from 6 to 2. So we dropped 4. So we're going to have a negative 4 meters. And then we've gone over from 12 to 16 seconds. So that's a change of 4 seconds. So a negative 4 divided by 4 gives us a negative 1 meters per second. So remember, a way to make sure and check that you got it right, this is a downward slope, which means we know it has to be negative. This here is an upward slope, so we know it must be positive.